Alright, hello. So I just want to make another quick video real quick to put in the database of YouTube. It's about, it explains the multiverse? No, yeah, that's right? There's the many worlds theory and the multiverse. They're different, but yeah, that's right, the multiverse theory or whatever. So anyway, right now the theory is that there's many universes, you know, and they each have different laws. Well, it's to answer the question, why does this universe happen to be so perfectly designed for us? And so sorry, somebody just woke up. Why is it so perfectly designed for us? And so their answer to that is, well, it's, you know, there's many universes, they all have different laws, different particles, and we just happen to live in one that's like this, you know, and that works for us. And so anyway, I made another video explaining, you know, an idea of infinite smallness and how forces can be fundamentally different on different sizes, like gravity might apply, or might seem like the strong nuclear force, might seem like the strong nuclear force at some level way higher. And but anyway, so this one is to explain another idea that I have, which is the fact that there's a whole bunch of particles that we keep finding, and this universe can be, let me get one more drag. The universe that we're in right now can be have a bunch of other particles that we just don't interact with in any way, and we keep finding particles like that. And there's other forces too that just probably don't have any interaction with us. So these other universes can be sharing the same space. And you know, this is actually a pretty like reasonable idea, because yeah, there is other particles like neutrinos. They don't really interact with matter, barely. And there's a bunch of other ones that seem to have no purpose, you know, and we thought we had them all found, and then we keep finding another one, keep finding another one. And you know, there's probably some that interact lightly, you know what I mean? Like, I should probably draw it out, but there's probably some particles, there's the few right now, you know, like quarks, electrons, and then protons and neutrons, I believe, are just quarks. But all of them, they interact with each other directly, and also directly through 3 out of the 4 fundamental forces. And gravity, you know, interacts with them as well, but it's different. It's another category. So that's almost like a force that it might interact with other particles that we just can't detect in any fashion. But anyway, on those other areas, like this universe, they might coalesce together, the forces and these particles we don't detect, in ways that are other universes. And so you know, there's probably a bunch of other particles, and it seems weird at first, because it's like, well, wouldn't we see them? But no, actually, most things are space. Most, like, you know, 99.9999% of everything you're looking at is space. It's just that we happen to be made out of particles that interact with other certain particles. Here, can I get that? And then also we've evolved to see the light that bounces off of them. But that alone, just the light, can't, you know, that spectrum is so large, and interacts with other, there's other, you know, there's infrared and yeah, gamma rays, all that stuff, you know. And so anyway, we just happen to see the ones that bounce off the particles that we interact with, because why else would we develop eyes that see these other forms of light if it has absolutely no use to us? So anyway, but that's the idea of it, you know, like if there's all these other particles, we have just recently even discovered some, like, you know, in the Large Hadron Collider, you know, and they believe that there's more, and we don't know where that would stop. Like, there could be thousands more, there could be millions more, there could be billions more, we don't know. And it's very possible that there's a bunch of other ones, god damn it, there could be a bunch of other ones that interact with each other just how like quarks and electrons do. And then there's probably forces in between them, like the strong nuclear force for us, and then the weak nuclear force for us, and etc., etc. So anyway, So that's the idea of it. So I mean, there's you know, these are probably all true. I mean, they are to a degree. I mean, we know there's other particles. We see dark energy. We see dark matter. They interact with gravity. So gravity would be like in between. So like, you know, here, let's say there's the four forces here. Gravity is the pinky or something over here. And there's all the particles that interact with each other right here. And they're going to like, you know, attach to each other, you know, bond with each other because of these forces that they interact with. And then gravity might interact lightly with these ones, but also some over here, like dark matter, because they do. Gravity does seem to interact with them, with dark matter. Those are probably other particles. And then there's probably even further. Those maybe have forces that interact with, and et cetera, et cetera. And then there's probably ones we don't even know of, detect, or in any sense, any form. And then the other idea that I posted with, you know, at different sizes, you know, like the strong nuclear force that holds, you know, a nucleus together. Think about, you know, if you expand and go much greater, like a galaxy. You know, gravity kind of acts like the strong nuclear force of a galaxy. And there is no limit to size. Like, it just, there's only practical limits to size. You know, like as far as like what we experience, what we see, and our best ability of detecting it. But if you really think about it, just imagine even the Planck length, which they say, you know, which is the, you know, supposedly the smallest amount. Just imagine you make yourself the size of the Planck length. Just a thought experiment. Okay, and then so now it's the size of you. Well, what about this little spot right here? You know, like this. You know, if it's the same size as you, there's this. Make your same size as that. Okay, what about that size? There's no limit in theory and an idea, and technically there isn't. It's just whether or not it's like quantifiable or scientifically possible to explore, or you know what I mean, like for us. But same with large. You know, I mean, technically, what if galaxies were atoms? You know, like we only see the observable universe because of how far light can travel. But what if it just was infinite to us? You know, like what if there was just, you know, I think, what is it, 10 to the power of 71 or something like that, atoms in the universe. And what if it was like that with galaxies? And you know, and then again, you know, like that, those coalesce to maybe make a form of life on that level. And what's interesting too is life kind of does that to a degree. Like first it was on like almost an atomic scale, like of molecules. You know, there was just a small chemical reaction that was able to, you know, the conditions were right where the chemical reaction sustained itself, and the chemical reaction was able to react in such a way to keep itself reacting. You know, like, and then it grew in time. It became, you know, more complex, more cells came together. And then it was on this level. And then, like the level kind of we're at, you know, of like complex beings. And then eventually, like the Earth is almost like a cell, you know. It's almost like a body in its own sense. That'd be like the next level up, you know. And this isn't necessarily my idea. I've gone further with it. But like, you know, like just look at roads. They're like, you know, like veins, you know, like nutrition, you know, whatever goes through them. The police would be the immune system, you know, like cells that are bad and having a bad effect on the body, you know. And then there's like even like bones, to a degree, things we wouldn't really think would be like part of this idea, kind of would be like bones could be kind of like dirt or mountains, you know, like as life ingrains itself in this planet more. You know, there really isn't much of a difference. Like, yes, like the bones, it's like, well, we developed those. But we could be to the point when we spread to other planets that we do something similar. We, you know, base ourselves off of an element, like calcium is the bone, and we build off of it and form it, you know. We form it like our body forms bones. We form the planet to suit the life form that the planet is, in a sense. Anyway, then those become cells. Then the galaxy, all the planets there are inhabited by life. Then those are connected. And then the galaxy is like a body, a very complex body, you know, and then it continues. So like, it's like almost like life started on some very, very small level, and it's just going to grow, not only like it's in our perception of growth, but on much higher levels. And it's you know, I don't know, it's interesting to think about. But anyway, so with that in mind, how forces interact differently with each other on different levels, you know, that's another thing. Like, it's it's not only necessarily like maybe we're in a universe where everything fit, but we're at the right size, we're within the right amount, like, you know, it just happens that these are the particles that interact with each other to create it. And so it's more like three-dimensional than the idea of there's more universes that are probably just have different conditions in them. You know, there's different layers of that, you know, like between all those factors, between size and the way that forces and particles interact with each other on different levels, and between all the particles that we don't know about and all those different areas of what could be reality. Between one of those places, there's bound to be a chemical reaction that is self-sustaining and self-replicating. And even in our perceived reality of planets and space and all that, that alone is pretty large. You know, out of all the planets, just a planet alone has a massive amount of surface area, and it's not two-dimensional either. You can go down and up, and any one of these places out of the quadrillions of planets, there was bound to be a clash of atoms that came together in a way that of what would create a cell. Just imagine a basic cell, not even a cell that exists now. Like a cell that exists now is obviously evolved for a long period of time, but the idea of life is a chemical reaction that gathers energy, and it allows the chemical reaction to continue itself as long as the conditions are right. And there's other ideas that this applies to that we've kind of seen in nature, like the natural nuclear reactor. Like, it's the same idea, because those would have to be precise conditions. You know, there'd have to be critical mass achieved for there to be a chain reaction without it dying off or going one way or the other. There'd have to be the right amount of water. Anyway, the conditions were just right that allowed a natural fission reactor on the planet in Africa. It's kind of the same idea, you know, it's the same thing. You know, there's a bunch of chemicals. Just imagine like a basic life form, like a very basic cell that just kind of took in heat energy. With that energy, it was a reaction that kind of like expanded itself to absorb more of what it was energy, you know, or from the sun or whatever. And it was probably in that state for a long time until, you know, amino fatty acids kind of like created a cell-like membrane that encapsulated this chemical reaction. And then it was in that form for probably a long time. And then, you know, we know by our understanding of science that life is possible, right? We just don't know how exactly it was created, but we know it's possible. So we can take the smallest example of life that we know of now, even though it would be much simpler, and the arrangement of those atoms is a quantifiable thing. It's just something that can be achieved, you know, in theory, right? But what would be stopping that from happening if you had a long enough of amount of time and a large enough of a place? You know, like, even if we say like, well, the odds of that, and it's true, the odds of that would be, you know, seemingly very, very small, because, you know, there'd be billions maybe of these atoms, and there'd have to be different amounts of them, and, you know, and there's probably multiple ways that the idea could be achieved of life, you know, but either way, as infinitesimally, I'm so bad at saying that word, infinitesimally small chance of that happening becomes pretty probable once you look at how much time has passed, all these other factors I've been talking about with size and all the other particles you don't know about, and how large just a planet is, just one planet, besides the fact that there's quadrillions of them. Then it kind of makes sense that there would be a form of life, you know? A form of life would sprout up. It actually would be kind of weird that somewhere in all these like ideas, and maybe the multiverse theory in its current form today exists to a degree too. Like, maybe there is other ones with different laws, but how would life not happen? You know? And yeah, that's about it. I'll leave it there. All right.